under velocity time graphs. In this video, we're going to learn how to calculate the distance of any moving object or its displacement using the velocity time graphs. For this matter, we're going to use two graphs that are on page 9 in the book. Graph A. First, we have on the x-axis the time and the unit is seconds, and on the y-axis velocity and its unit meters per second. Now let's assume I have a horizontal straight line, and this line represents an object moving at a steady speed, which means it's neither increasing nor decreasing. And the value is 5 meters per second. The time taken to move is 10 seconds. So if we want to calculate the distance, we have two ways. The first one is using the speed triangle. In this case, we can take the equation d equals v times t. According to the example we have in the graph, v equals 5 meters per second and t equals 10 seconds. So 5 times 10 equals 50 meters. A body moves a distance 50 meters in 10 seconds with average velocity 5 meters per second. Another way is selecting the area under the line drawn, and the shape here is a rectangle. So what we have to do is get the area of a rectangle so we will be able to get the distance. Area of a rectangle equals length times width. From the graph, the length equals 5 meters per second and the width is 10 seconds, equals 50 meters, which is the same answer as the one we got using the speed triangle. So we conclude that the area under a velocity time graph is equal to the distance traveled by an object in a particular time interval. And instead of distance, we can also use the word displacement of object, and we've already discussed the difference between the two in the distance and displacement video. Now we're going to take another example, graph B, and get the distance traveled by this object represented in the graph. This graph shows that the object is moving at an unsteady speed. It's increasing with time. First, we select the area under the line, and it's obvious that the area is a triangle. So what we have to do here is get the area of the triangle under the line. Area of a triangle equals height times base over 2. Height from the graph equals 10 meters per second, and the base is 4 seconds. So 10 meters per second times 4 over 2 equals 40 over 2. And the final answer is 20 meters. So the distance traveled by the body is 20 meters in 4 seconds with an average speed 10 meters per second. So now we're able to get the distance of any object from the graph by only calculating the area under the line.